Hi everybody, this is Haruna. And
hi, this is Rashmi.
And this is Nick Gonzalez.
Welcome to the third session of the Integrating Scratch webinar series. So we finished the first two sessions, which covered backdrops, sprites, and today we are going to move into conditionals and broadcast, which will let you add a little bit more interactivity to your program. And then we'll finish off next week with variables and taking user inputs. Today we will look at a couple of the projects from week two sample homework, homework projects. And then we're going to go into the meat of this week's session. And I'm going to show you the record video option, which I've been trying to do since last week, and I never got to it. And then we'll talk about the homework. Okay, so again, this is the Teacher Studio, where I put everybody's shared projects. And the first one that we will show you is this one. And if you recall, we actually showed this one last week as well, but it's been added to, so we are going to show it again.
I'm going to show you how to walk from the Winship School to the nearest public library, the Brighton branch of the Boston Public Library.
Just integrates Google Street Views, and you have a really good...
First, as you walk out of the school's front door, you will see a traffic circle with Dighton's.
I'm going to pause it. Go ahead.
Aaron's project is really amazing because he has built on it from what we've seen last time. And you can see that the arrow really indicates the integration of Google Maps. And Runa, would you like to add to that?
Yes. So he added the arrow as a sprite. And the arrow moves according to what the map is showing at the time.
I'm going to show you how to walk.
And he utilized the glide feature, which is great. He did it
right
to simplify
the Public Library. It's located at 40 Academy Hill Road.
I'm going to let this play for a little bit longer.
Right.
First, as you walk out of the school's front door, you will see a traffic circle with Dighton Street extending down the hill in front of you. Turn right on Dighton Street. As you turn right, your street view will look like this. Walk 1 block to Chestnut Hill Avenue. Cross Chestnut Hill Avenue using the crosswalk.
So I'm going to stop it right there again. And notice how the placement of the arrows is very deliberate, and also the direction it's going to. And he has the arrow pointing to different directions depending on the where in the program it is. So sometimes it's set to 0, sometimes it's pointing to 60 degrees or minus 60 degrees. So he matched the arrow up with the map. And made sure it was in the right place, facing the right way, and moving in the right direction.
Right.
So we thought that was very nicely done. Anything else to add to this one?
Just the seamless change of the backdrops, and you see how the positioning, again, as Aruna mentioned, the seamless positioning of X and Y makes it more a deliberate movement as opposed to a random movement.
Right.
Go back to the studio. Was there another one you wanted to show, Rashmi? That one?
Right. Template. If you could go inside the code.
Okay.
A couple of things that we looked at, you see that there are a lot of costume changes that are happening in this project, and so emphasizing that they're not necessarily sprites but costume changes within the sprite. And secondly, also we wanted to refer back to Aaron's project and seeing how notes and credits are attributed, and any background images that we take, they're also included in the notes and credits. So just sort of re-emphasizing the importance of giving credit to any external media that we bring in.
And that's inside this notes and credits section. So when you share the project, when you click on share, you get this project page, and you can type things into there to give credit. So those are the two projects we'll share for the time being. And let me switch my slide back. I just want to repeat this slide that I did last time about supported file types because we got additional questions about this during this week's project. So again, the images that are supported are JPEGs, PNGs, and SVGs. And if you happen to be using your L4L and you do a screenshot, it saves it as a TIFF file, which is not one of the supported file formats. So you can, if you have some sort of image editor in your computer, you can use that to convert the file, like if you have Photoshop or something like that. If you don't, you can use an online service. Zamzar.com is a really easy one, but there are other ones out there. If you just Google file conversion, you'll end up with a bunch of different sites that can do it for you. And then the same thing with the sound. It supports WAV files and MP3 files. So if you have any other sound source, you're going to have to convert that as well. So going into this week's projects. So we're going to show some examples of interactive projects to just let you know what we mean by it. And then we'll get into the actual programming of it. So we'll show 3 projects. All of them are in the example studio. So I'm going to go into my stuff. And my studios, because it's under my studios, example studio. So the first one I will show is the water cycle project.
The water cycle.
It has an introduction that shows you what you need to do. So this is, once your project is interactive, it's very important to give people instructions.
So in this project also, if you see, it's a really great model to create an interactive diagram or the environment in Scratch. It uses simple costumes, and when we go inside and you'll see the code, there are multiple sprites, but they are meant for very specific purposes. So that's a great way of modeling an interactive program. It also uses broadcast control. Haruna will talk about it a little bit more, and sort of, you know, launching the sprites into action that allows for a lot of this interactivity. So maybe Haruna, if you go inside.
Yeah, let me click in one of them and just show you what happens. So if I click on word, as the instruction told me to.
Cloud formation occurs as a result of the processes of transpiration and evaporation.
And you can see more information about that. So this is like a clickable
Runoff
infographic.
includes a variety of ways by which water moves across the
Just
land.
quickly.
This includes both surface runoff and channel runoff.
It's got tons of sprites. A lot of these sprites could have been a background.
Right, exactly.
Incorporated into the background, but they made it into different sprites, which is okay.
And if you click on maybe one of the, it allows, as Haruna mentioned, they could be background and the trees can be placed all over the place, but some of, like the sprite 30, they have code, and you can see that, you know, they are letting, for cloud formation, there is some text. For rain, you have some rain coming down, so there is motion. So this is a great way of modeling. Obviously, we don't expect you to have 50 different sprites and program them, but it's a great model to look at.
She also has sound programmed as well. She puts sound, and there's an explanation every time you click on the sprite, which is really nice too.
Yes. And so, and if you look at each sprite, you see that each one has a separate script. So that's the way different sprites work. Usually all sprites will have its own script. And some of them will not have any script, like this tree.
Right.
One advantage to making tree into a sprite rather than part of the backdrop is you can move it around.
Right.
So in the paint editor of the background, once you draw it, there's really not too much that you can do to undo and edit the picture. But if you do it this way, you can resize, you can place them, you can move it around much easier than if you made it part of the backdrop. So,
especially with the clouds.
So that could be why this user decided to use it as a sprite.
Absolutely.
Another one I want to point out is these evaporation and the rain and that. It's a nice little animation. It's actually just 2 costumes that is flipping back and forth that give it a nice moving effect. So that's a really nice, neat use of costumes. The next one we're going to show you is the cell, and just sort of by coincidence, this week's projects are all science themed.
We'll watch it for a minute.
So this one, if you scroll over
it gives
different
you
parts, it gives you a description of the different parts.
Absolutely. I also like how the notes and credits are quoted and really clear instructions.
And it even has the standards on there.
Absolutely, which is an added bonus. Definitely, it's really well done.
Yes, and I love the graphics. It's
absolutely.
Very beautifully drawn. The last one I'm going to show you is one that I made for this webinar series. All of these images come from the NASA's library. NASA has a really wide range of publicly available space images.
Royalty free.
Yep. And in this one, each of the planet and the sun is a different sprite. And it's made to show what it is when I scroll over with my cursor. And if I click on it, it blows up. Everything else goes away. It blows up, and the little character will tell you a little bit more about it. And then after it's done, it goes back to the original graphic, and you can keep on going to the other ones. So this is sort of what we mean by a clickable infographic or an interactive program, and that's what we'll be going after this week. And I am going to go ahead and start showing you some of the pieces that you will need to start building something like this. So I'm going to go ahead and click on Create and start from a blank slate. I will name it Planets again. So first thing I'm going to do is I'm going to add, so I'm not going to make the exact same program I was just doing. So instead of the little alien type guy, I'm just going to use this cat in the interest of time. And I am going to use a pre-existing image rather than importing from the NASA's website. So let's say this is one of my planets. I'll just rename this. Let's call this Mars. This is my rendition of Mars, and I'm going to see if I can find the other one. Earth. All right, so I have 2 planets and a cat.
Scratchy.
Scratchy the cat, yes.
That's his new name.
Oh, before I do that, actually, I totally forgot. I'm going to go back to my slides for a second and talk to you a little bit about conditionals and what they are. So today we are going to use something called a conditional, which will give you different responses depending on the condition. So in the case of the planets, we had, if your mouse was touching the planet, then it showed the name of the planet. So in English terms, this is one example. So a condition is something that gives you a true or false answer, or yes or no answer. So if the condition is it is dark, if it's true, that means it's dark, and you will turn the lights on. And in this case, if it's false, you're not going to do anything. So this is one type of a conditional called if-then, where you have some sort of action when something is true and no action if something is false. Well, in real life, if you do this, you're going to wait till it's dark and you'll turn the lights on, and then that's it. You'll never turn it back off, which is probably not what will happen. So in real life, a lot of times if then else is a little bit more appropriate. Else also adds an action for the false case. So in this case now it's dark. If it's true, then you will turn the lights on. If it's false, you will turn the lights off. And this way, the lights doesn't stay on forever. Now, in most programming cases, so if you do this, let's say you do this when you wake up in the morning. You see if it's light or dark, and then you turn the lights on or leave it off. You don't just do that once a day. You keep on doing this over and over every time you pass by the light switch. So that's, in programming sense, that's using a loop. So usually these if-thens are used inside a loop because you need to keep on checking for the condition. Otherwise, you'll check it once, and then the program moves on, and you never check it again. So very often, these things are used inside a loop so that you keep on checking for the condition, and you choose the path depending on what's going on. So back to my program. So in Scratch, if you go into Control menu, there is if-then, which again is you only have action for when it's true. And you also have if-then else, which gives you 2 places to put condition. And if you see this little icon, it's a little bit hard to see. Let me blow this up. There is a hexagonal space where you can put your condition. And your conditions are found under sensing, although there's some other ones somewhere in other places as well. All the conditions in Scratch are used as hexagonal shape. So it's these things over here and this one over here. I'm going to start out with this, the touching one. And conveniently, there's something called touching mouse pointer. So that means if the Earth, and notice that I'm on the Earth, I'm programming the Earth right now. If the Earth is touching the mouse pointer, then I want it to say Earth. Right? So, and I'm going to put the green flag on. Now, if I do this, notice that the program runs and then stops right away because it checks this condition once and just comes to the end of the program and stops. So this is where we need the loop. So I'm going to put this inside a forever loop. And now if I run it and I touch the Earth, it shows up with Earth. But if I do this, once I take my mouse cursor off, the caption doesn't go away. So this is the same case as the light staying on forever.
That's why you need that.
So I will take this out and use the if then else. But I'm just going to copy all of these over. And I'm going to put a blank say block in here.
Choose a planet.
So now it says Earth, and when I take the mouse pointer off, it doesn't say anything. All right, so that's a really easy mouse over script. Now let's say I want the Mars to do the same thing. There is an easy way to copy this code from Earth into Mars. We said before that in Sprite, in Scratch, every sprite has its own script. Right. Too many S words. So once I have a working piece of code in Earth that I know I'm pretty much going to duplicate in other sprites, I can take this and drag it over and drop it into this Mars right down here. Now it doesn't look like anything happened, but now if I click on Mars, it's right there. And all I have to do is change this caption to Mars. And because each one has a green flag hat on it, once I start the green flag, both of the scripts start at the same time, and they both work perfectly. So.
And many times when we copy codes in sprites, the codes look exactly similar. So on the right-hand corner, top corner, you see sort of the image, faded out image of the sprite. So if she moves to the Earth, you will see Earth. And so accordingly, you can make changes to your sprite, so you know you are in that sprite.
And you need to be very careful that you know which sprite you're working in, because you don't want to make changes to the wrong sprite.
Absolutely.
One other thing you can do with if-thens, this is one place where you might want to use ifs, if-thens rather than if-else, is, let me take that out once. So there is also a sensing thing called key pressed. It's out of the way a little bit more. And I can say if the right arrow is pressed, move 10 steps. And what that does is, if I press my right arrow key, which you can't see me pressing the key, but the sprite moves to the right. And I can duplicate this for the other arrows. And now we easily have a controllable sprite that can move back and forth by key press. And you can also do this for up and down or whatever combination of keys you want.
And the way Haruna did that was she right-clicked on the if statement.
I'm going to get rid of that since I don't want my Earth to be moving right now.
It is moving.
Yes, but not in a straight line.
Exactly.
Okay, so I think, so if then else, I think we're okay with it. Now I'm going to move on to something called broadcast, which is a very interesting concept that is fairly specific to Scratch. Now, broadcast is under events, and it's a tool used in Scratch to let, how can I explain this? Let sprites talk to each other. So because each sprite has its own script, it's very difficult to have something in Earth trigger something else in a different sprite. But using broadcast, that's what you can do. So broadcast is kind of like a signal that one sprite sends out that can be heard by everything else. So all the other sprites, as well as the backdrop or the stage, will get the broadcast. And then you can code the other sprites to do something in reaction to that. So I know that didn't really make sense, but so one of the things I can do is there is a when this sprite clicked hat. And anything I connect to this will happen when I click on the sprite, which is Earth. And I'm going to say broadcast, change the name of this. I'm going to broadcast Earth. So that means if I click on Earth, it's going to send a signal to all of these other sprites and the stage, this little message Earth. And now my little cat, when I receive the message Earth, then I can say Earth for 2 seconds. So now let me run this again. So we still have this captions going on. If I click on this, now the cat will say Earth.
It's literally the cat is radioing Earth, and Earth is receiving the message.
And broadcast is really the only way in Scratch that you can have one sprite talk to the other and synchronize motions and events between different sprites.
Absolutely.
And the backdrop. So that's one way of using broadcast. And in my other planet program, I had all the other planets hide when I click on one of the planets. So I can also do the same thing over here. So I can say when I receive Earth, hide. And I'm in the Mars script right now. So once again, I can run it. When I click on Earth, the Mars goes away. But now, we need the Mars to come back. So
in the loop.
What we can do now is after the cat says Earth for 2 seconds, I can send another broadcast. And I can say something like done. And I can say in Mars that when I receive done, then
show Mars.
Show. And actually, I should put this up here too, so that it makes sure that it shows up when I first start running the program. So now I click on Earth, Mars goes away, cat says Earth, 2 seconds later, everything is back to normal. Okay, so you can have these sort of intertwining broadcasts. It gets a little bit complicated, and you need to. It's a little bit challenging to keep it straight in your head, but you can have multiple broadcasts going back and forth, and that's. When you create your broadcast, you can rename it, or you can create new messages, and it's really important for you to name it something intuitive, that's something that makes sense, so that you don't get it all confused. If you just call everything message 1, message 2, then it's very easy to get it all confused.
Absolutely.
And so what I'm going to do now is I'm going to copy this into Mars, just like I did before. And then whenever you copy a script, it shows up on this top left. So it's going to show up right on top of the code that you already have. So just know that it's going to show up right there. You might think, oh, it's not there, but it is. I'm going to create a new one called Mars. And I'm going to copy these 2 extra ones back onto Earth. So both of them are going to show up right there. I will move them away. So for the Earth, I wanted to hide when I receive Mars. And then in the cat, I'm going to duplicate this and say when I receive Mars, I will say Mars. And obviously this can be sound, or this can be, it can say more things than just Mars and Earth. So now if I click on Mars, Earth goes away, cat says Mars. If I click on Earth, the cat says Earth, and the Mars goes away, and so on. And that's sort of the beginnings of my planet program. The only other thing I had was the planets kind of enlarged, but that's everything that happens. You already know how to work with size, and I think you know how to make things move, so I think we got all the pieces that you need for that. And we had a question about sound in one of the homeworks. So sound exists for each sprite. So all the sprites by default, well, the cat comes with the meow sound by default, and most other ones have some sort of a sound effect by default that comes with it, and this one is a pop. Let's say I imported another sound, or recorded one. So I'm not going to record, I'm just going to import one called dance around, so that Earth now has a new sound effect. This does not show up in all of my other stuff, including the other 2 sprites or the stage. So if you were in one of the sprites when you recorded the sound. That's the only place you'll find it.
Mm-hmm.
Now, if you want to copy this to the other sprite, you can do the same thing you did with the script. You can just drag this and drop it over the other sprite,
Right.
and now it shows up on the Mars as well. So if you recorded some narration in one sprite and you need to use it in a different sprite, you can just copy it by dragging it over and dropping it into the sprite. And you can also do that with the stage. You can drop it right into the stage and you'll see that sound effect. So that's the easy way to share different sound effects between the different sprites without having to re-import it all the time. Okay, so I do want to show one feature that I've been meaning to show that I never got to. That is the record project video feature. This was added a few months ago in Scratch. If you go to File, so if you want to share your Scratch project, but you don't want the person to have to log into Scratch and all that, you can just say File, Record Project Video, and it will record a video of your project up to 60 seconds. You can have options to include sound, show mouse pointer or not. You can record the entire editor, which means it'll record this right pane as well. If you unclick this, it'll only show your stage and what's going on there. And you can click Start, and then whenever you're done doing what you're doing, you click this little square. So I can play my script, and you see the bar going across the bottom telling you how much time you have left. And when you're done, you just click Stop, and it saves it on a file. Now, it doesn't save this on the Scratch server. You need to save it locally on your computer. And it downloads it right away. But you do need Flash Player to play it. So that's the only caveat. It's not going to be a movie file. You're going to need Flash Player to play it. But other than that, it's a really nice way to be able to share things, and you can create videos that way.
And even the VLC media player that they talk about is available for free, which plays multiple media formats, so that's accessible to you as well.
So for your homework this week, again, we're going to have the exit ticket. The questions are slightly different this time. And then your assignment is to make some sort of an interactive slideshow or an infographic with the following elements. At least 3 sprites. And these are not costumes, sprites. Costumes are different appearances within the sprite. And at least one of those sprites should be clickable, and it should do something when you click on it, or it or some other sprite should do something when you click on it. You should use broadcast. And I would like you to, I would like to encourage you to use instructions and credits as either part of your project or in the project page. So you can have the instructions display right on the beginning of the project, or you could have it in the credit page on the project page. And then again, submit it through Google Classroom. You can use your existing project or start a new one. And just some examples, we show you science-themed examples to share. I mean, this week, but there are other other things you can do. So, for example, you could have a clickable map that history
showcases,
themed.
Right, exactly.
So maybe you can have different sprites that are shaped like different countries that kind of form a map, and then you click on them and different facts show up about different countries.
Or even continents.
Continents, yeah.
Yes,
you can do a timeline where you can click different parts of the timeline and show historical events.
Timeline in terms of even timeline of computer science.
Yeah. You can also do something more like a story like you were doing before, but have the pages advanced when you click on a certain. You could have just page advancing icons or buttons to advance the page, and that way the students could read it in a self-paced way. So those are different options you could do. So it doesn't need to be a science theme. Again, if you need help, you can send us email. I know a lot of you have been working on these during the weekend, and we're a little bit slow to get back to you over the weekend, but we will try our best. And again, we will have Thursday office hours again.
I'll be there.
Yeah, Nick will be downstairs at the first floor lobby, 4 to 5 p.m. And then both of us will be online 3:30 to 5. So you can reach us there. This is, again, repeat of what we said before. Plan before you begin, especially with the broadcast going back and forth. You really need to plan what you want the sprites to do. Otherwise, it could get confusing very easily.
Absolutely.
Test as you go. So
Write small snippets.
yeah. So again, if you're using my planet one as an example, I'm not going to line up all the planets and program everything before I test. You know, I'm going to test one planet, and once that's working, I will copy the code into the other planets and make little changes. That's a much easier way to do things than programming the whole thing and finding out something is wrong.
Right.
And then you have to go through everything to figure out what's wrong.
There are always multiple ways of solving the problem, and computers do what you tell them to do. So
Yes, they do.
we program and we tell them to do what we need. Yep. Next one.
Don't be afraid. Feel free to play around. Scratch will not break.
Absolutely.
And I've tried many times and it doesn't work. Scratch does not break. Exactly. No, the way to really learn Scratch is to get your hands dirty.
Exactly.
Don't be afraid.
Thank you for tuning in.
Thank you so much. Scratch away.
This is a short one, but we will be back for the next one. So.
Yeah, absolutely. Short and a great one.
All right. Have a good evening, everybody. Bye-bye.
Thank you, everyone.
Thanks for tuning in to our webinar. If you learned something new, give us a thumbs up or leave a comment below in the comment section. If you're looking for more DLT videos, click on one of the videos on the left side of the screen or explore our YouTube channel. Please don't forget to subscribe.